Okay, I'm going to do another transistor design circuit project here, and I found a YouTube channel here called philomech, and he did a really nice series in a playlist here. It's called Selectable Latching Relay Circuit Series, and he did a very nice job in explaining and designing right from scratch using the design process, everything, how to design a selectable latching relay circuit, and that's using manual switching relays and transistors instead of microcontrollers. And like I said, he did a very nice job in explaining the tutorial, and I recommend it's a good one to look at. And what I want to do now is I want to design a selectable latching relay circuit, but instead of using mechanical relays, I like to make it out of all solid-state transistors and probably use SCRs. And so that's what this here tutorial is going to be about, that I'm going to do here. Stay tuned. Now there's no need for me to explain the circuit, how it functions, because he explains it in his tutorial really well. All I'm going to do is explain how I'm going to make changes from using the mechanical relays to using SCRs now instead. So now for a solid-state device, a good one would be to use an SCR. So if I put an SCR in here, so let's start out with an SCR. If I use an SCR here, I need a way to turn the SCR off. So what I'll have to do is put a transistor in here, an NPN transistor in here. And then we'll put a current limiting resistor to the positive side of the battery. Then I'll need a way, as I said, in order to turn this SCR off, I'll have to be able to turn the transistor off. So we want the transistor to be on continuously as a supply to the SCR, because we're going to have the load. The SCR is going to be syncing the load LED. So we need a transistor bias on here with a base resistor like that. In order to turn the transistor off now, we need we'll use a diode switching, and we have one that we'll use for all clear, and then we need two more for A and for B. If this is A, for B and C we'll make it. In other words, for the other two latches to go into that. Then on the SCR input here on the gate, we will have an input, and then we'll have another NPN transistor that will be used to drive syncing current to the base of the other transistors that will turn off those latches off. And of course here would be our LED load to ground. Okay, that should take care of one latching circuit. This transistor is on the anode side of the SCR. It's continuously biased on, so it has a positive current pull through here, or I should say a positive bias on the anode here. The gate input turning on a transistor here to turn off the other latches, but we'll also put another resistor here for gate input. At the same time, we will tie this here. Okay, that resistor there is good. Okay, so let's go ahead and build this and see what we end up with here. Do this to make this more clear now, and I'll explain what's going on with this. What we have here is our SCR. That's going to be our latch. We have the gate right here is tied to a 10 k ohm resistor that will go then to a normally open and push button. The load is an LED that's being driven off the cathode side of the SCR. And then on the anode side, we have a 2N3904 NPN transistor that's going to be driving and syncing, supplying current to the SCR here. And this supply current here is going to be the base of this is biased on through a 10 kilo ohm resistor, and then through a current limiting resistor 330 ohms to limit current through the LED. And right now, when the SCR is off, unlatched, because the push button has not been activated yet, then we have the 2N3904 is providing a positive bias to the anode side of the SCR, but no current is flowing yet because the SCR is not latched on yet. When we hit the apply a positive voltage to the gate of the gate of the SCR, then the LED should light up. If we put a negative pulse to any one of these diodes here, these like 1M914s, then that will bring the base down low and cause the NPN transistor to turn off, which would then shut down the SCR, and then the load would go low again, and it'd be ready for another input again. So let's go ahead and build this now, and we'll test this out, and we'll have to build 3 of these after this. We're just going to build this and test this one first. We have it built here now. We have the SCR here, the LED being the load. We have our 3 diodes right here going into an NPN transistor. Everything is biased back here, and this is the input to the gate of the SCR. I'm going to use this here white wire connected to the positive side of the battery to touch on to here. And when I touch this, the light should go on and stay on when I take the input off. Now this wire here is connected to the negative side of the battery, and if I touch any one of these here diodes, the SCR is off again. So through every 3 diodes, first diode, second diode, and the third diode. So what we have here is we have accomplished is that we have a way that we can turn the SCR on and turn the SCR off. Now we're going to go ahead and build 3 of these, and then we're going to show how we're going to connect them together, interconnect them together with transistors in order to get these selectable switching to happen. Okay, here's my collection here. SCRs, NPN transistors, LEDs, and switching diodes, and my collection here of components, things. Okay, so now what we did is we built this circuit 3 times, duplicated 3 times, and right here it is. And what we like to do is always give it all a test, so make sure they all come on. Okay, and now we want to turn them off, hitting the LEDs, or hitting the diodes, switching diodes, and they all go off. So we know now that it's working properly to that extent there. We know that we can, again, like I said, it proves out that we can turn on and turn off each one of these, so we know they're all connected properly. So now we need to start thinking about how we're going to make them work with each other so that we can push a button and make them switch selectively. And that's what's coming up next now, the design of that. How do we make the selectable part of this now? What we do is we're going to, we have our input here, so we know that we have to do the selection on the input. Okay. So what we need to do is we need to turn on another device. Let's go with an NPN transistor, and let's put its emitter to ground so that we can be syncing current. And as I've been saying before, I've been using syncing and sourcing in kind of backwards here, but the load is here on the anode side of the SCR, so the SCR and everything above the load here would be sourcing current through the load. Okay, this here transistor here is going to be syncing current because it's going to be syncing current to the load up here. The load is going to be above it, and that load is going to be these here latching cells here that we're building. We're going to build 3 of these, and what we need to do is we need to be able to turn this transistor on, and it's going to send a negative signal into the diodes of the other latches, and that's all we need is 1 NPN transistor, 2 N3, 9, and 4 again. And because it is on the ground side of the load it's going to be driving, then it will be syncing current from the load here, and these loads will be these transistors here on the other latches here. So we'll go ahead and build 1 of these here. Well, what we'll do is we'll just start building these now, and then we will check and see how that turns off the other ones, and we'll experiment there. So let's go with it. Okay, so let's get a brief explanation of what's going on here now. These cells right here, these represent the other 2 latches, and that's this part right here. Okay. So what we do is we take each transistor from each latch here, and this one here would go into one of these diodes, and also into the second one as well. And this would then ground these bases here to turn those latches off. This would be latch 1, 2, and 3, A, B, and C. So we need to put this transistor to this one here and do the same thing for their two latches, which I have done here so far, this part right here. And so now I need to connect the buttons and everything. But what we're going to be doing is getting these here lined up on the LED, on these here diodes here, so that we can get them switched. And then we also need to make a way that we can take the last diode here, or I should say the first diode right here, connect all of them together at one time, and that would be our master clear button. And we'll see how that works as well. That's coming up. Get it all built here now. I can remove the test wires I was using. Don't need those now because I've got buttons in here now. And the circuit's completed. We have our first one here, first cell, the second one, and the third one. This button here would be the all clear. That's connected to the negative side of the battery. These three switches are connected to the positive side of the battery. That's our positive input. And let's give it a try. Go ahead. This one turns that one on. That one turns that one on. That one turns that one on. And we go back and forth here. We can play all kinds of things here with it, so you can see how it works. And let's go ahead and check the clear. Okay, so we put this one on. Here's all clear. That goes off. Second one, all clear, goes off. Third one, all clear, goes off. Okay, so it works. Okay. So now we did it with solid state, all solid state components. And there's the schematic for it right there. And a pretty quick explanation of it and everything. And what I'll probably do is I'll draw the schematic up and make it look a lot better and neater, and then I'll let you see how schematic works, and we'll look at the schematic and explain a little better what's going on here. But it does work using SCRs, and it's all solid state now electronics, no mechanical relays, and it can be done this way as well. And that's the circuit right there and its functionality. Okay, we'll get a schematic going here now, and I'll show you how the circuit's actually drawn up now. That's coming up next.